Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 23 for the February daily LeetCode challenge, and we again have a question on trees. Okay, let me recall what we have seen till now. So yesterday we have seen a hard level question on trees. Okay, around the same topic. Okay, that was also a question in which we were creating the whole tree from scratch. This is also a such question like that. Okay, we'll compare both the questions, how it is different from yesterday's question. But again, I will recommend that you try out yesterday's question because you were learning a lot from that. Okay, using same logic, some of the same logics we'll be coding today. Okay, so my request will be to go and see that question once if you have not done that. Okay, now coming to this question, this is going to revolve around the topic of what is a pre-order traversal and what is a post-order traversal. Okay, so today I will be explaining in detail like what are those. Okay, like I will be just mentioning the pattern which is followed to determine the pre and post-order traversals. We'll learn about it, but my request to you will be, before watching this video, do Google once what are these things. Okay, I mean to say that, see, DFS can be implemented using three ways. Okay, in case of trees, one is the pre-order, second one is the post-order, third one is the in-order traversal. Okay, so if you see the combination using pre and post-order, you cannot predict directly the exact sequence of the tree. Okay, that's why in this question, if you see, they are mentioning there are multiple answers possible. Okay, but had it been like this, see, had they given only pre-order and a in order, then then we would have exactly predicted the whole tree. Okay, there will be only one answer in that case. Okay, there won't be multiple answers like this. Okay, but in case of pre and post order, if they are given and you are asked to predict the whole tree, in that case there can be chances of multiple answers, and that is why in this question they have clearly mentioned if there exist multiple answers, you can return any one of them. Okay, so we'll discuss the whole topic, but my expectation is that when you are coming to this video, you have already gone through the question. If you have not done that, always feel free to take the link of the question from my video description, and go through it once, see the examples, and then come back to this video. Okay, that will ensure that you are capturing everything that is being said here. Okay, that is the only intention that I'm doing this video. Okay, now let me quickly jump in because we have already gone through the question. I will just highlight some of the important points. See, here we are just given pre-order and post-order. Okay, remember, just one more time, let me repeat it. You are not given the tree, you are just given the traversal sequences. That is, if we do the traversal of a tree in pre and post, what will be the sequence? You are just given that sequence. Okay, you are just given that output. You are not given the tree. In the question, the demand of the question is that you will have to create this whole tree and then return the root of the tree. Okay, that is the question. And as I mentioned in the starting itself, the way they have defined it, post and pre-order, you are given only these two. If you are given these two, at most you can just create a one possible tree. There could be other possible answers. That's why they mentioned this point also. Okay, we will discuss this point also at the end of the video, like why I am saying this and why, like, okay, when we discuss this part, that time it will be clear to you. Okay, now, so yep, and one more thing is it is a binary tree. Always remember these traversals like pre-order, post order, in order, these are defined only for binary trees, because if you see, there is a component of left subtree, right subtree coming in this. Okay, so that is only possible if you have a binary tree. Okay, in a graph you will not have this kind of stuff. Yeah, there is DFS for graph, but you will not have in order, post order, pre order in a graph. Okay, let me just tell you this thing so that you are clear. Okay, you have a clarity on what we are doing. Okay, now let us quickly begin with this question. So we are given pre order and post order, and we will have to define the whole tree. Okay, now I will tell you like how to use both of them. Okay, see, one thing is clear, like we have seen yesterday, the order in which you create the nodes is going to be in a pre-order. Okay, but then what is the requirement of post-order, we'll get to another. Okay, if you remember in yesterday's question, we were given the pre-order traversal, but we were also given the depth of the nodes. Okay, so just to check, for example, see, if I am at 2 and the next node is 4, if you see here, 2 is here and 4 is here. Okay, so when I am at 2 and the next node is 4, I just want to know whether 4 is going to be a child of 2 or 4 is going to be a different node altogether. Okay, it's not related to 2. I just need to know that link. Okay, I just need to know that connection. But how do I know that? Okay, for knowing that, in yesterday's question they had given a depth. Okay, so I was just checking whether the depth of 4 is equal to depth of 2 plus 1. If that is the case, then I can be sure that yeah, 4 is going to be a child node of 2. Okay, yep. But in this question you are not given the depth of the nodes, so how do we know that? You will have to take the hint from this. Okay, now, for knowing how this works, I will be first explaining you how are these things defined. Okay, what is pre-order and what is post-order. So because without knowing this question will be slightly on the tougher side for you to understand, because even if you know like little by little what is pre-order or post-order, still to connect all the dots you still need a better clarity. Okay, without that you will not be able to understand this solution. Okay, see, for that, what first of all, what is pre-order? Pre-order, the word pre is coming because the root is being processed first. Okay, the root is processed first, and then the left subtree, and then the right subtree. Okay, so before the subtrees, the root is being processed. That is the most important part. That is the reason why it is coming pre-order. Okay, yep. Similarly, in case of post order, as you might have already guessed, before, first of all, the subtrees will be processed. That is the left subtree and the right subtree, and then we will process the root. Okay. You will now ask me why I have written 4 into here. I will come to that. But just understand, the left subtree will be processed first, then the right subtree, and then the root. Okay. If you ignore the subtree, just ignore this part. Just understand, all the child nodes will be processed first, and then at last the root will come. Okay. That is the only idea, right? Now let us come back to our the actual problem that we had. If I am at 2 and the next node is 4 in the pre-order, how do I know whether 4 is a child node of 2 or not? Okay, how to know that? So for that reason, I will take the help from post order. Okay, in the post order, you see what is happening. All the child nodes are processed first, and then the root is being processed. Okay, so in this case, let us assume that 4 is going to be a child of 2. Okay, that is the case. That is the actual case here. In that case, what will happen? Since 2 is the root, it will come at last, and since 4 is, a child node, it will come before 2. So if you see the actual order, see 4 is coming here and 2 is coming here. Okay, that means, can I conclude in this way, that in the post order, okay, if the index of 4 is less than the index of 2 in post order traversal, we can conclude that 4 is going to be in the subtree of 2. Okay, I will again repeat. If you want, please pause the video, maybe please go back, rewind, and do whatever you want, but please understand this point. The whole question is revolving around this. Okay, I will again repeat. In the post order traversal, if the index of 4, okay, is less than the index of 2, okay, in post order traversal, then can we conclude that 4 is going to be in the 4 is going to be a child node, or you can say, 4 is going to be in the child subtree of 2. Okay, can you conclude that? Yes, we can conclude that, and that is what we are going to do. So in this whole post order, the only thing that we will need is the indexes. Okay, I will just, for example, see, let me take a random value. Let us talk about 6. Okay, let us talk about 6 and 3. Okay, now 6 is coming in this index, 3 is coming in this index. That means the index in which 6 occurs is definitely coming ahead of the index in which 3 occurs. So I can conclude that 6 is going to be a child node for 3. Okay, as simple as that. Okay, now don't ask me like, see, 4 is here, okay, 1 is here. That is, see, they're not distinct. Okay, I just need to know a parent child relation only. Okay, I'm not talking about very far relations. Okay, for example, see, 5 is here, 3 is here. Okay, let us talk about that. Okay, 5 is here, 3 is here now. Okay, so let us see their indexes in the post order. So 5 is here and 3 is here. Okay, as simple as that. So the idea here is, after 5, okay, when I'm at 5, first of all, I will try to see what if 5 has a child node or not. Okay, so I will see 3. Okay, I've done with 5. Okay, now I'm trying to create the next node. Okay, so when I visit 3, I should know whether 3 is going to be a child node of 5 or not. Okay, so for that reason, I will just check the sequences. If you see, 3 is coming here and, okay, 5 is coming here. Okay, but that should have been the reverse. Okay, 3 should have come before 5. Okay, because the root should come here, child node should come before. So had 3 come before 5 in the post order, then we would have concluded that, yeah, 3 is going to be a child node of 5. But that is not the case here. Okay, the index of 5 is coming before, and then 3 is coming. That means definitely this is not the case that 3 is going to be a child node of 5. Okay, that is not the case. So that is how we will be doing this part. Okay, I hope you're understanding what I'm saying. See, don't try to like link too far, like two very distinct values. We just need to know the relation between a, parent and child nodes. Okay, for example, 2 and 5, 2 and 4, similarly 3 and 6, 3 and 7, and so on. So that's why we will be, see, after 5, when you go to 3, you will be clearly knowing that, okay, 3 is not going to be a child node of 5. Using this, the 5 is coming here, 3 is coming here. Okay, what should have been the case? 3 should have come first, and then 5 should have come. Then we could have concluded that, yeah, 3 is going to be a subtree of 5. Okay? So this was the logic. I hope you are getting this logic. That's why I mentioned, see, 2 is here, 4 is here. So since 4 is coming before 2 in this case, so we can say that, okay, see, 4 is here, okay, 2 is here. So we can say that 4 is going to be, definitely it's going to be in the, child subtree of 2. Okay, as simple as that. So let us quickly see how we are doing this. See, see, as I mentioned, like we have seen yesterday's video, we will always create the nodes in the pre-order only. Okay, we will create the nodes in this sequence only, but only to check whether a particular node is in the child node of a current node or not. For that reason, we'll be using their indexes in the post order. Okay, so I hope this point is clear to now. Okay, so let me quickly dive into my solution. See here, I am creating a dictionary. Okay, it's a default dictionary. Default dictionary means it's going to be a key value pair. The value is going to be the integer. Okay, so I'm calling it as a post. Okay. So now, as I mentioned, always I will use post order only to confirm whether a particular node is coming first or a second node is coming first in the post order sequence. Since I'm bothered only about the indexes, for example, say I'm talking about 5. So what is the index in which 5 is appearing, and similarly what is the index in which 7 is appearing in the post order? I'm only worried about the index. So what is my requirement? If I pass a number 7, I need to know the index in which it is appearing in the post order. Similarly, if I pass a number 2, I should know the index in which it is appearing in the post order. Okay, for that reason, I'm creating this key value pair. So the key in this will be the value itself. Okay, I mean the number itself, and the value will be the index of it. Okay, in the post order. I hope this point is clear. Let us quickly move forward. Then I'm creating a next index. This thing I already used in yesterday's video. So see, whenever we are doing a DFS and we are creating a whole subtree, it's always better to declare this next index. Okay, what is the next index, by the way? It is basically the node in which we are doing the current processing. Okay, this is the index for this pre-order array. Okay, so it will tell the index in which we are currently processing this array. Okay, this will be from like 0 till n-1. Okay, like this. Okay, so let us say I'm at 4 currently. I'm going to create 4, so next index will be pointing to that index. It's going to be representing the index in the pre-order array, right? Now n is going to be the length of post order or pre-order. Anyway, you can take it, you can also make it as pre-order or post order, right? Fine. No, I'm going to fill this, okay, dictionary. For that, what I'm doing, say I'm going through indexes from 0 to n-1. Okay, I'm taking the value is going to post order of I, and the index in which it appears is going to be I. Okay, the value is going to be post order of I, and the index in which it appears is going to be I. Okay, as simple as that. So whenever I pass a value in this, I will be getting their index, okay, in the post order traversal. Okay, we will be using this to know whether a whether the next one is going to be in the child node of the current node or not. Okay, now this is my defense function. This is almost similar to what we have seen yesterday. Obviously, like, see, questions are different. Yesterday the challenge was different, today the challenge is different, but again the idea remains the same. And similarly, these are the basic function calls. Okay, like, if you see, these are outside the recursion function, and these are the this is the actual code in this. Okay, in the whole. Okay, finally we're writing the root. So one more thing that I want to tell you, see, always before I pass, like always before I call the DFS for any node, that node should be already created. Okay, that is the unwritten rule that I'm following. Always the node should be created, and only then the call should be made to that node. Okay, that is the basic idea. Okay, you should always follow it. See, like, I am always following it. It's up to you. If you want, you can do that. But yeah, what I'm doing is, in my code, I will, in my defense function, I will not be checking whether this node exists or not. Okay, that I'm not writing that code. Okay, I always ensure that the node already exists, and only then the defense call is being made. Okay, when this, in this defense function, okay, in this function, but as you will see, we are only creating the child nodes for the current node. Okay, we are only creating the child nodes for the current node. We will not be creating the node in itself. The node should already exist. Only its child nodes, if they are required, will be created. Okay, as simple as that, right? Now, okay, one more thing, okay, that I did not tell you, that can you quickly explain me why is this the case? Okay, why are they saying there are multiple answers possible? See, one thing that is there is, see, for example, you are in root. Okay, you know that if, see, let us say one has a child 2. Okay, now one will come here and 2 will come here. Okay, but you don't know whether 2 came for the left subtree or 2 came for the right subtree. That means there is definitely confusion. So you are not very much clear. See, for example, if you are given the in order result, what is in order? In order will mean you will definitely know, okay, this node, this particular value is coming from the left subtree, this particular value is coming from the right subtree. Okay, that is definite there. But in case of post order, what is happening, always the left subtree will be processed. Let's say if the left subtree is not existing, then the value will come from the right subtree. Okay, but we will not know for sure whether the value came from left subtree or right subtree. Okay, that is a disadvantage here. Okay, so that's why they are saying there could be multiple answers. There could be a scenario where the answers could be multiple. For example, let me give you one scenario. Let us imagine this whole tree is there. I mean, like, in this whole tree, only there are two nodes. Okay, one and two. Let us say in this whole tree, only one and two exist. Okay, one is going to be the left subtree of, one is going to be a left child of, sorry, two is going to the left child of one. Okay, now when you do this post order, it will be difficult for you to know whether 2 is coming from the left subtree or right subtree. Okay, okay, because see, one of them will be, okay, not existing, in other one will be pointing to 2. Okay, it's difficult for you to know whether 2 is in the left subtree or the right subtree. Okay, that is difficult for you to know. Okay, that is the reason why, similarly in this case, see, you can mark one here in the pre-order, but yeah, among them one of them will only come. Okay, because other one is not existing. Okay, so it will be blank there. Okay, you will not write a blank in the output, but yeah, it just means that, yeah, that value is not existing. Okay, so you will just write 2 here, but you will never know whether the 2 was in the right subtree or the left subtree. That is the reason why there could be multiple possibilities. That's why they mentioned that. Okay, but let us say this question comes in interview and you are asked, so what could be the case that, let us say, you are given the choice whether you want pre-order. Okay, you are given the choice among pre-order, post, or in order. You can take two of them, and then you can, but you have to get a definite answer. Okay, you should not get multiple answers. Can you quickly tell me in which two case you can get the definite answer? The answer will be if you have a pre-order and if you have in order. Okay, in that case, yes, you can get a definite answer. Always remember, in order is mandatory. If you have in order and at any one of pre-order or post order, I will again repeat, if you have in order and any one of pre-order or post-order, then yes, you can get a definite answer. Then you will not have multiple answers. Okay, that is something that I want to tell you before I start the video. Okay, yep. Now this is going to be my defense function. Again, as usual, everything that is being referred from outside of this function will come in non-local. Okay, now, as I mentioned, always the route should be created before calling this defense function. Okay, so before, after enter the defense function, the first thing that I will do is allot the value to this root. Okay, root dot val is equal to pre-order of next index. Okay, this next index will be already incremented, and this will point to the value in the pre-order that we are going to process. Okay, for example, say 4 or 2. Okay, let us say 2 now. 2 will be allotted to this root dot val now. Okay, now I will do next index plus plus. Okay, then I will do this part. This part will ensure that if the next node, so for see after 2 4 is coming, so that 4 is going to have a next node. That's why I've done next index plus plus. Currently it is pointing to 4. Okay, will this code will just ensure if at all 4 is going to be a subtree of the current node, that is if 4 is going to be a subtree of 2, then this code will be helpful for you. Okay, let's see what is happening. We are just checking whether next index has crossed and or not. Okay, if next index is less than, only then go for it, because if next index equal to 1, that means we are already creating all nodes. Okay, already all the nodes are created, no need to waste your time. Okay, so this is why I'll always include this condition. If this condition is true, that means we'll just check whether the index, okay, the see this particular value is going to be representing 4. Okay, 4 will be represented by this whole value. Okay, this whole value represents 4 now. Okay, now we'll just check whether the index of 4 in the post order, okay, this means the index of 4 in post order is is it less than the index of 2 in post order. Okay, I will again repeat, the index of 4 in post order is less than index of 2 in post order. I'm just checking whether that is the case or not. Let us see. Index of 4 is this, index of 2 is this. That means the index of 4 in post order is going to be less than index of 2 in post order. That means 4 could be possibly existing as a child node in for the root, for the node 2. Okay, so that's why what we'll do root dot left is equal to a new node. Okay, we'll create a new node for the root dot left, and we will pass that in the DFS. Okay, see, remember this code and this code, okay, though they are exactly after each other, but remember this is a recursive function. So between this code and this code, there will be a lot of things that are happening. Okay, for example, see, when I call this thing, okay, let us say I am at 2. Okay, I call this thing, but when I execute this part of the code, okay, I would have be at 3. Okay, see, we were at 2 when we called this code. Okay, then we will be at 3 when this code is executed. Okay, what I mean to say is, see, this is a recursive function, right? And this is a global variable. Okay, so just have that thing in mind. That's what it is happening. Okay, so yep. So see, when you are at 2 for calling, so see, when you are calling for 4, when you're going to create the node 4, you will be calling this part. Okay, and when by the time you come here, you will be at 5. Okay, as simple as that. Not 3, it will be 5. Sorry, I mentioned that wrongly. Yeah, when you are, see, for when you are at node number 1, the two nodes will be 2. Okay, 2 and 3, and this is the case. Okay, so for when you are at node number 1, when you have to create node number 2, in that case this will be helpful for you. And similarly, when you are about trying to create node number 3, this will be helpful for you. Okay, that's what I'm trying to tell you. If you see this condition and this condition is exactly the same. Okay, it's exactly the same, only difference is here we are creating root dot right, we are creating a new node here. Similarly, so here root dot left, and similarly here root dot right, we are creating a new node, and we are passing root dot right here. Okay, in the diffs. So this whole function will continue to create all the nodes in the order of the pre-order traversal. Okay, and then we'll finally return the root. Okay, so I have explained this part also, and I've already explained you, if you are given an in order traversal and any one of the other, okay, any one of the other two, then you can definitely get a exact answer. Okay, but in this case, since in order is not given, we have multiple possibilities. Okay, so we have written any one of them. So yeah, fine, that was all for this video. If you talk about space and time complexity, see, always I mention this thing when we are talking about a graph, right? So if you talk about DFS in a graph, your time complexity will be you n plus e. Okay, where n is the number of nodes, e is the number of edges. But in case of trees, especially the binary tree, since the number of edges are very restricted, and I can say that the number of edges are constrained with the number of nodes. For that reason, the e will not come in case of binary tree. It will be only o of n. Okay, so in this case, if you see, this particular part will take o of n time. Okay, similarly, this whole thing will take o of n time because we are creating n nodes as such. Okay, yep. And if you come to space complexity, again the same thing, we are creating a key value pace which has n keys, so it will take off on time, off on space. And similarly, we are creating a whole new tree, okay, which has n nodes, so again that will take off on space. Okay, so both space and time complexity are going to be off n in this case. So yeah, often that was all for this particular video. I hope you get some insight of what is happening here, especially the logic that if you are given any two traversals, you should be able to create almost a similar tree, is what is we are trying to learn here. Okay, as simple as that. So yeah, that was all for this video. If you like the content, if you like the quality of this video, then please do subscribe to the channel. This will ensure that multiple people who do not have access to quality resources, especially the paid resources, this kind of videos will be helpful for them. That is my intention of creating these videos. So if you subscribe, maybe like LeetCode will recommend this kind of videos to them, and they will be able to learn something good, something of good with good quality and content. Okay, that is the only aim that I have. Okay, because when I was a student, I did not had access to this quality content. So yep, even I relied on YouTube videos, some free articles and all that. So that is my, like, that's my way of giving back to the society. I am just trying to create videos with some quality content, okay, so that everyone who like is new to coding, who doesn't know much, or maybe he's in need of resources and he's trying to uplift himself from his life, then yep, so these kind of videos might be helpful to them. So if you like the content, if you feel it will be useful for someone who doesn't have quality resources, then please subscribe, so that you lead this YouTube and LeetCode, they promote this content and it reaches multiple more people. Okay, so this was my 124th day of continuous lead coding. Let us see how many more days it comes. Let's hope for the best. See you tomorrow. Thanks a lot.